Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is Rich Boberg. Rich is CEO of Turbine. Hey, welcome to the show, Rich.
Thank you very much, Rich.
Hey, I understand that you have some slides for us. Do you want to go through those?
Okay, thanks, Rich. So, as the title slide shows, I am Rich Boberg, the CEO of Turbine, and our product that we're announcing as of May 24th is called Accelio. Next slide. You can see on this slide, we're focused at hosts used for virtualization. And our technology, which addresses how to accelerate the I/O for applications, allows more kinds of applications to be used that would otherwise only be suitable for standalone or bare metal systems. We're focused at, this shows one host that's typically in a cluster with a hypervisor kernel such as VMware ESX and multiple virtual machines running on top of that. This is really one unit of a cluster, so if you click the next build on this slide, you'll see there's shared storage that's typically used to serve an entire cluster. We just showed one host, but typically you'll have a storage network with many drives in the primary storage depicted at the bottom of that slide. If you click the next button, you'll see the bullet at the right, which indicates the number of CPUs or cores is going up rather dramatically in each one of these host physical servers, which allows people to run more, users to run yet more virtual machines to use those cores, which really dramatically increases the amount of demand in I/O in aggregate within one host and certainly down to that primary storage which is trying to serve the next host. This tends to give you some limitations to the applications you can serve because each VM is sort of treated equally from an I/O performance. Our software is to try to address this. If you do one more click, you see that the gap between the CPU and the disk speed is getting bigger. You're having many more CPUs, but the spindle speed is not going up. You do the next click, enter into the scene flash technology, whether it's on PCI cards or disk drive form factors. The big advantage of flash is in dollars per IOPS. It's more expensive per gigabyte, but much cheaper if you can focus your IOPS onto flash, which is basically where we're focused at. Let's look at the, click to the next slide. And in this slide, the diagram on the left is very similar to what we were just seeing, but I've added the characterization of primary storage down below to indicate that you're trying to satisfy both capacity management as well as performance management at that level. The capacity management refers to your normal persistent storage, mirroring, both local and remote mirroring, backup, snapshots, and so forth. But at the same time, you're trying to provide the ultimate of performance in IOPS. If you do one more click, you see that you add flash up in the host. This would allow you to satisfy IOs much faster, and therefore our objective is actually satisfy those IOPS there and instead of in the primary storage. So if you do one more click, you see you can actually reduce the number of spindles because a lot of those spindles were just purchased not for their capacity but for their IOPS. And the more IOPS you can satisfy close to the application means you can run applications that are very I/O sensitive. And that's really the primary potential benefit. One more click and you can see our software is what resides in that host server, both at the hypervisor level and in the guest OS and the VM virtual machine to allow that to happen. let's do a click to the next slide. And actually, if you could click that 2 more times, Rich, to build this basically where we left off in the previous slide. So you have IOPS being satisfied by the flash, but how do you make this happen? If you look at a normal architecture from the application to the primary storage, if you click one more time, you'll see what we call the emerging, initially it's the existing architecture. From an application, usually accesses memory and storage from the CPU through L1, L2 caches and DRAM. In the virtualized environment, then you go through a virtualization layer of the hypervisor over the storage network to your disk. And this is what slows the IOs down, going over that storage network instead of having local attached. If you click one more time, you see that what we do is add into that memory to storage or disk architecture is the flash layer. We actually look at flash as more, rather than a fast storage device, really like an extension of DRAM. And we primarily use it for caching, the hottest, most used data, so you get the most bang for your buck out of that, the gigabytes of flash that you would install in your server. If you click one more time again, it depicts Accelio, our software, that allows this to happen. In a second, we'll look at how this works in a more granular basis. But the ultimate notion here is that you want to satisfy IOs very close to the application itself, because this allows you to take a number of applications that were otherwise only applicable to bare metal systems and to put it on a very high performance server, but get the IO performance that you need. If you click one more time, you should go to the next slide, which is called the Accelio deployment diagram. So Accelio, our software, really loads into 2 primary places to address this IO performance. One is in the virtual machine itself, which could be any guest operating system, Windows, and in the future we'll be supporting Linux and other applications, as well as a module that plugs into the VM kernel level, the hypervisor level, which we call it a VLUN or virtual LUN driver. And all this does is really manage the flash capacity on behalf of those VMs. But one of the primary things it does is you can give priority to one VM over another for this use of the flash as cache for IO acceleration. This allows you to import a application that otherwise may have been suitable only for a bare metal system into a virtualized system. And certainly for existing applications, you can, again, provide a priority amongst the VMs for which one should have the most acceleration. And the flash that's depicted in the lower right side of the diagram on the left, that can be a PCIe card. It can be a SAS card or a SATA, SSD, if you will. All it needs to do is look like a block device to our driver, and then we allocate it amongst the various VMs according to a fair share model. The other primary thing this does, aside from just using that flash very efficiently, is allow those VMs to come and go and perhaps vMotion move to another host dynamically. And then we allow it to happen. Normally, as a low-patched storage, that would not, VMware, for instance, wouldn't allow that to happen. So those are the primary characteristics, and then there's management software, which manages that, since you've got potentially tens or hundreds of hosts and thousands of VMs. We have a very advanced graphical user interface, very similar to VMware's vCenter, to manage that. If you go to the next slide, slide 6, you see the basic advantages of Accelio are really across high performance, significant cost savings, and it's really simple to administer for especially a large deployment. From a performance standpoint, by having the I/O satisfied very close to the application, you accelerate the application, but you also get even more usage out of your CPU, not waiting on I/O waits. And therefore, you can actually get more throughput per application, and you could run more applications on the same host and get the advantages that way. Also, what's very unique about our caching, the basic caching capability, is we can cache on a block level, a disk, but we could also decide to do caching just on a volume level or really on a file level using wildcards on the file. So you can decide, without modifying the application itself, you can modify what gets cached and what doesn't get cached. So you don't have to change the number of disk drives, and because you can only cache on a drive level, you can really decide it just using a standard application ported to this environment. The IOPS savings from primary storage can be dramatic. A typical spinning disk is 100, 150, maybe 200 IOPS. A typical SAS SSD is tens of thousands, 50, 60,000 IOPS. For every 10,000 IOPS you could offload from your primary storage, it could save 50 to 100 spindles, spinning disks. So immediate cost savings from that standpoint. We use the flash very efficiently because you mainly have your hot data in the flash. You're not wasting gigabytes of flash with unused data just for regular storage. Because we basically are a read cache or a write-through cache. And so in our 1.0 product, future products will address some of the persistent data issues in cache. And it really, and this is what drives home to the HPC market, is there's some class of applications which could only be run on bare metal systems, which could now more cost effectively be run in a virtualized environment as you address the I/O limitation otherwise. And all of this is done very transparently from an administration standpoint and continues to support all the virtualization basic capabilities of vMotion, for instance, that people want to use for HA, load balancing, or just for maintenance purposes on production systems. So on the final slide, the next slide 7, the unique advantages in solving the I/O bottleneck in virtualized systems. Right now, you can't even use flash in these environments because it acts as a local attached disk, which is sort of antithetical to virtualized servers. And now you can use them very efficiently and effectively because they're used as cache for the hot data. It delivers the IOPS right burst of the data, so performance goes up instead of at the other end of a storage network where you can add caching or someplace in between. You can have a very fine granularity control over that down to a file level. And the setup is very transparent. You don't have to reconfigure your application or your storage configuration or your hypervisor storage virtualization in order to have this I/O performance improvements, resulting in faster performance, better utilization of your primary storage, and better utilization and higher density in the hosts you're using for virtualization. So hopefully this, for your audience, Rich, this allows some class of applications to move to virtualization. Certainly not all HPC type applications, but for the ones that are applicable, allows people to run more applications in virtualization and run them with the speed necessary.
As far as I'm thinking of how you configure this, you've got this flash device and then your software layer. What's the ratio servers to that device and that setup? Is it a 1-to-1 or is it a rack full of servers do this? How does that work?
So the flash itself gets installed either as a PCIe or a SAS SSD, or one or a few of each one of either one of those into a physical server. And so the flash is contained within the server itself, and so the amount of flash you need, which would typically be in the maybe hundreds of gigabytes, maybe up to a terabyte, can really be tailored to the types of applications or virtual contained in the virtual machines on each server. And then again, you can have that flash installed in multiple physical hosts in the cluster. And that's what allows you to, if you do vMotion, move an application from one physical host to another, you could then take advantage transparently again of the flash in the target host.
So Rich, I assume you've had some beta customers. What are they saying about this? What kind of reaction are you getting?
So the beta customers are sort of amazed. There's some running like OLAP type applications. There's a lot of just the if you will, the back office enterprise server apps. There's Exchange servers and so forth. And what most customers are amazed at is they install this, and without having to reconfigure their application, they say, hey, everything is running 30% faster, and that's presuming they apply virtualization across all of the apps. So there's quite a variety response, because when you ask people in the general virtualization space, okay, what kind of apps do you run on your virtualized servers? They say everything. So the response really has been pretty broad with the various apps that they're running.
So theoretically then, if you were to compare the performance of this against a bare metal setup without any flash, could this potentially be faster than the bare metal without the flash?
Certainly could be faster. That's a very good point. I mean, typically in a bare metal environment, to use flash, you usually partition your storage such that you have some special files that or data, subset of your data that you want to be accessed very fast. So it's a lot of work to do that, but presuming you're not up, that doesn't make sense in a particular application for sure. Then if you run that application in our environment and without having to do that special reconfiguration of the data, highly likely it would run faster. A general virtualized system like running VMware, they look at the CPU cycle overhead being about 7 to 8% of that for the hypervisor functionality, if you will, the ability to run multiple VMs. But when you have 48 cores or more, say 12 CPUs, each with 4 cores, you can have a lot of CPU power on there, and the CPU overhead is not the big factor.
So just, I guess, kind of a wrap-up question, Rich. My friend Josh Simons works at the CTO office at VMware, and he was trying to describe how big that market is compared to HPC, and he said that VMworld was something like 18,000 people, versus our big supercomputing show is maybe 11,000. What's the potential market out there for something like this? Is it sky the limit right now?
It's very large. Just right now, the last numbers I saw was something like each year there's about 1.5 million virtualized physical servers sold, and that's growing at a remarkable amount. So it's already a large installed base, because that's been going on for several years, and it's growing from there. So this software could be used on existing servers because it's essentially installable on existing installed base. but that 1.5 new servers per year really indicates that you've got a very large and growing market for new installs too.
So if any of our listeners are getting their ears perked up on this, Rich, how hard is it to get set up and kick the tires on this setup?
It's pretty. You even have a profiler mode where you can, and it will actually work. The basic caching will work on a standalone system, which is probably optimal for your listeners. So just that module that we showed plugged into a VM, into a virtual machine, that can plug into any bare metal system as well. In particular, right now we're supporting Windows 2008, so we don't have our Linux version available, which I know is very common in the HPC market. But we also, in that, and even without the flash in that environment, we have a profiler mode that would, if you have an application that's running on that OS, you can run it and see what kind of caching hit rate you would end up getting for a particular application in real time. So you can go to our website is www.ioturbine.com.
Well, terrific. Hey, Rich, thanks for coming on the show today. And I'd love to check in with you maybe 6 months and see how this is going. Does that sound good?
That would be great, Rich. I really appreciate your time and look forward to talking to you in the future.
Okay, thanks again. That's it for the Rich Report. Stay tuned for more news and information on high-performance computing.